Right. Hi, everyone. My name is Xiang Li, and I'm a software engineer at Retool. So today, I'm going to talk about what is Retool, where we are, and where we are going. And I'm gonna I'm not gonna demo the application development in Retool, but I'm gonna stories. So what is Retool? So our mission is change the way that all software is built. This is a kind of like high-level overview of what the Retool UI looks like. It's a modern way to build customer enterprise applications. You can basically use Retool to connect to any of your database, for example, TiDB, Snowflake, MySQL, whatever. And also you can build your interface with our 90 plus pre-built components, including like say table views, list views, JSON viewers, all those stuff. And of course, you can write code within Retool. You can write custom logic actions using JS, SQL, CSS. And here is the current list of all the resources or database we support. You can see all list here, Postgres, MySQL, Microsoft SQL, or etc. And also we support like APIs like REST API, GraphQL. And you can design with pre-built components. This is how it looks like on the right side. You can basically drag like a table view and populate your data and drag a drop down. You can add something like filtering or text input. So you don't need to spend all the time tweaking all this JavaScript, HTML, CSS to see how the UI looks like. Right? You can just drag and drop and get the task done within seconds. And of course, you can customize everything with JavaScript and SQL if our current functionality doesn't fulfill your needs. And after a few drag and drop, some code writings, you can launch a fully functional application within Retool. And you would significantly reduce the time to develop an app, maybe from days, weeks, just hours, or even minutes. So we have a large community of developers, and the developers all love Retool. You can search for all the tweets about building stuff within Retool. So currently, we have more than 130,000 developers within our community, and we have built a lot of relationships with our enterprise customer too. You can see here a list of Amazon, DoorDash, Brex, Coinbase, etc. And also, this is our basically fundraising journey. And because our mission is to change the way all software is built, we have attracted investors from companies with similar ideas. You can see Stripe, GitHub, Relation, and they have all changed the way software is built. And Retool, this is a high-level overview of how the Retool is structured. And Retool is the fastest way to build internal application, especially, is because you don't need to do all these tedious repetitive tasks with JavaScript, and you don't need to do it from scratch. You can just get the job done with it.
So, so as I drag and drop, Retool creates the JavaScript.
Yeah, Retool create the JavaScript, and you can just populate data within one line of code. To populate data comes from your API or database, etc. Yeah, anywhere you want.
So I can imagine this kind of like a template, but in application level.
A template?
A template for it's because we just need to populate the data and just yield control flow to Retool, right? Okay.
So Retool basically built the template for mostly UI in the front end, and also you can connect to any API. So because the data is whatever you want to control.
Definitely.
You want to control the logic, you want to control how data are populated. Retool basically provides the template to how to build the front end UI and template with all these components. So you don't need to do it from scratch. For example, writing HTML, CSS, or JavaScript. You can just focusing on the functionality.
Gotcha. Thank you.
And another question I usually get from people is like, what is Retool no code or low code? So we are not actually against no code. We believe code is necessary. We believe low code in the future means software engineers should just focus on the important part without doing all the tedious repetitive work. But you should still write code because coding is actually very necessary to build customized functionality to fulfill all your business cases. So in the following, I will tell some stories from our current customers. Hopefully, it will be interesting and inspiring for you how it can be. So this is an example from our one of our largest customer, Coinbase. So Coinbase decentralized the internal tool building for its engineering team using Retool. So each team can have their own Retool instance. So they can set their own permissions and dedicate all this app building process to not just engineers, but also people like PMs or financial analysts, whoever can write some code like SQL or JavaScript. You don't have to be an expert. So one example app they have built. If you have used Coinbase before, you will maybe have the similar experience as me. Like getting the tax report from Coinbase is super hard. You have to manually pass all these transactions to get your tax reported correctly. So this is a high priority request from Coinbase customer. And the customer success team can just verify the details and generate tax report and building this app by themselves. They don't really need to involve like front-end, back-end engineers and have a really long turnaround cycle. They can just build within Retool within days. And here's another example from DoorDash. So DoorDash actually built a ton of internal tools on Retool. Their whole different business use case or life cycle is dependent on Retool. And the scope of their internal building was like 2+ years, or each app took 1 or 2 months. But using Retool, they can just build it within 30 or 60 minutes or days. And like roughly estimated, they saved like more than 50x time. Here's another very interesting example from Retool customer. So as you can see, the previous 2 companies are all what we call like traditional tech companies. Coinbase, DoorDash, they are all based in Bay Area. They have tons of engineering resources. But for this one, NBC Universal, you won't treat it as a like traditional tech company, but they can still leverage on Retool. So in this example, NBC Universal data science team, they use the machine learning models to predict like what TV shows should I forecast, what would the views be in the like future, so they can arrange their TV program. But they don't have like tons of engineering resources to build all this tool to help them with that. So their data forecasting, basically who knows some JavaScript and SQL, can basically build this simple tool using Retool, and they run all these ML models each week. They have just visualization built on top of Retool, so they can see exactly what the model predict will be. And they can have a really fast feedback cycle with their client, who can make suggestions, who can make predictions, and decide where to invest. And believe it or not, they actually built a whole like Tokyo Olympic game like forecasting schedule completely on Retool. So they use these models built and visualization built on top of Retool to see like which games they should forecast. And they can use this ML data to make better decisions, which result in like huge impact in not just money-wise, but also like on how you can view the Olympics, like the whole world. And so far, you might have questions like how exactly I can build on Retool and how much like knowledge I need, for example, for JavaScript or SQL. Here is an example like from our customer from NBC Universal explain like whether they need tons of knowledge on JavaScript. Basically, what I'm trying to say is just like you don't need to understand You don't need to like have a tons of JavaScript and SQL knowledge to build on top of Retool. Very simple query, like select from tables would achieve a ton. And you can like write API calls.
If you have a URL, you can send to the chat window. That would be great. Maybe we can do it later.
Yeah, we can do it later. So overall, like Retool is a modern way to build custom enterprise applications, given whatever business case you need. For example, Coinbase, they need tons of operation apps. They need fraud monitoring apps. And for DoorDash, they need to, like, say, block certain zip code when there's a storm, or they need to operate all these like returns from DoorDash orders. And for NBC Universal or KFC, they need to focus on Olympic Games. But maybe tomorrow they need to focus on another game. You don't need to have all your engineering team involved to build one-off apps. You can iterate really fast on Retool for all your different needs. And also, in order to support our enterprise customers, we have built all these enterprise level features, including SSO, permissioning, version control, and you can even host Retool on-prem in your VPC. And also, you can host it on-prem, so you can just connect to your most sensitive data and financial data or PII data, because we don't touch any of your data and we don't know your data. Security is one of our top priority because our customers' lifeline depend on Retool. Okay. So here's a summary of what I kind of like described, a list of what Retool can help your team operate. You can decrease your time to market from months to hours or days. And you can just build a fast Retool app, adapt to your specific problem. Because you can build it fast, you can build more apps, of course. And you can also collaborate internally to build a live and visual collaboration on top of Retool. And you can have high flexibility, including not just software engineers, but also other non-engineers, people within build these apps. And another very important thing is like you can have your best engineers working to solve new and innovative problems. As we all know, like in Bay Area especially, it's really, really hard to find good engineers. With Retool, you can leverage on Retool and have your engineers build really critical apps. And of course, you can leave the maintenance to us. So you don't need to worry about maintaining these old, long-running apps or one-off apps. Cool. So basically, in a word, Retool is a local platform for you to design, to code, to connect to your data, and launch a fully functional app. So this is about Retool, and you might be wondering like why I'm here in PingCAP's meetup. So as you can see, like for Retool, a lot of our use case or customer use is building dashboards. So building dashboards involves you have data, you have things that you want to visualize. And you might think one interesting area where we have tons of data and public and we want to analyze is crypto or Web3. That's why I'm here, because PingCAP and I collaborated. We built an NFT dashboard on top of Retool and TiDB. And so now I will turn it over to Chenhao to talk about his NFT demo.
Cool. Yeah, I think I do like the introduction of Retool, especially the customer storage. They are pretty impressive, and I also like the look and feel of the Retool applications. So I think Retool's value proposition is really reduce the time to market, and TiDB actually have the same philosophy and same goals, but we tackle from different angle. We tackle from database angle. And next, I think Chenhao will talk about how we can use Retool and TiDB together to build a real NFT Insight application within a couple of days. Yeah. Chenhao, it's your stage.
Yeah, sure. Thank you. Okay, cool. Okay, cool. So just now, Xiang gave us a very impressive speech to show us how flexible Retool is and how easy to use Retool is. But to build a real-time insight system, there is still a very important part missing, which is the database. So today I'll be introducing you TiDB, especially on TiDB Cloud. So TiDB is a distributed SQL database. It supports high availability, ACID, strong consistency, and it is open source. So today, my title will be building an NFT Insight dashboard with Cloud Database and Retool. And during my presentation, you can see how to build a NFT Insight with 10 times faster performance more. Okay, cool. So I'll be starting with what is NFT. So NFT stands for non-fungible token. These beautiful tiny digital pictures here are all NFTs. So they are unique and can't be replaceable. As you can see, the red one and the green one are not identical. Some contrast example would be, for example, Bitcoin. So one Bitcoin equals another one Bitcoin. Another contrast example might be banknotes. Everyone's banknotes are as green. So most of the NFTs are on the Ethereum blockchain. So it is just a blockchain similar to all other blockchains like Bitcoin. Okay, what are NFT Insights? So as you know, there's a huge number of crypto analytics system in the world. They are trying to analyze all sorts of the crypto blockchains, etc., etc. So there's also a kind of crypto analytics system which is called NFT Insights, which focuses on analyzing these NFTs. I'll give you a couple of examples. The first one is Crypto Slam. So it's just rank NFT collections by all sorts of the different parameters. A more popular one might be Dune. So on Dune, everyone can publish its own dashboard and show it to everyone else. Okay, the next thing I want to talk about is why should we actually care about NFT Insights? Because firstly, so crypto analytics is a large market. The Dune analytics I showed you before on this page, this Dune analytics reached $1 billion US valuation recently. And also, crypto analytics can help you to guide your investment. For example, in the crypto market, the Web3 market grows very, very fast. There's huge opportunity there. And what's more important is the price just fluctuates a lot. And those price fluctuations means there's an opportunity for you to make money. Okay, so the building NFT Insights is also quite challenging for many databases because they are, first, we really need real-time insights. The obsolete data, the old data are kind of meaningless to us. And also we'll have to do the real-time analysis in the real time. You have to run the query very fast. As we know, the huge price fluctuations in Web3 market, so every second counts. And also the data set is usually quite large. It cannot be fitting into one single node. And lastly, the investors and the observers may ask all kinds of queries to the system. So the queries are quite flexible, and we have to prepare for that. Okay, TiDB. So in TiDB, we have existing customers to build crypto analytics apps in production environments for ad hoc queries. Okay, cool. So today I'll show you how to build an NFT Insight prototype within 10 minutes. So I'll first show you my Retool dashboard. Okay, so here's my Retool dashboard, NFT Insight dashboard. So as you can see, there are a couple of questions there standing to different database. We'll revisit this dashboard later. And just now, Xiang told you how easy it is to use Retool. So to integrate TiDB and Retool together, what we only need to do is firstly insert a connection string. This TiDB connection string is provided by TiDB. So just copy and paste this connection string into Retool, and that's done. And after that, you can write SQL queries, just normal SQL queries here. Yep, so it's kind of simple. Okay, going back to my slides. Okay, so I'm now going to introduce you the data sets used for this prototype. So the first table is the asset table. These tiny little pictures here are all assets. And we use a table called assets to record all this information as an ID, name, collection slug. I'll explain what collection slug is on next page. And we also have owner ID, etc., etc. We also have a index on the collection slug. So here's a sample table for the assets. We have asset ID and owner ID, etc., etc. We also have asset URL. I will click this URL. So, okay, as you can see, if you click on this URL, you can see your asset. This is a CryptoKitty. Yeah, moving back. Okay. So, and the second table we have is the collections table. So, as you can see, these figures, these similar digital figures, they're actually from the same collection. The first collection is CryptoPunks, and we also have CryptoKitties. Within each collection, there's actually a huge number of assets, huge number of NFTs. They all look similar to each other. So for the collections table, we have the collection slug as the primary key, and then collection name and URL. I've also included here a some sample records for collections table. Moving on. The third one and the most important table is transaction events table. So in one transaction events, a NFT is traded from one person to the other. So for each event, we have record event ID, time, asset ID, collection slug, and for example, event quantity, payment symbol. We also have index on collection slug and asset ID, which will be served as a foreign key to reference to other two tables. Here is a some sample data for the transaction events table. Okay, so just to summarize these three tables, I provide an entity relationship diagram here. So events is the most important table for us. We have event ID as a primary key. Now we have foreign key, we have reference from asset ID, which will reference to the asset ID in the asset table. And we also have collection slug, which will reference to the collection slug in the collections table. And for asset table and collection table, for these two tables, collection slug will be used to reference from assets table to the collections table. Okay, the architecture of the NFT Insights. So all the data are from OpenSea API, and one copy of data are sent to TiDB Cloud, and the other copy of data are sent to the Aurora. And we will later on compare the performance side by side, and the data are visualized by Retool dashboard. Okay, so why use Aurora MySQL as a comparison? So firstly, online serving is a must. Online serving is really a must. That's why we didn't consider the data warehouse solution. And also MySQL, Aurora MySQL is quite popular. So that's why we choose Aurora as a comparison. Okay, finally, the dataset size. The dataset is only a bit less than 3 gigabytes. We use a very small dataset because firstly, due to the limitation of OpenSea API, we can only send 4 queries per second to the OpenSea API. So it's already took us a long time to get these data. And secondly, so we will have a workshop and hands-on workshop later on. So a small dataset would be a good start for everyone to try on this, to experience TiDB and Retool. Okay, cool. So let's now jump to the NFT Insight dashboard. So this is dashboard, and we have 4 queries. These queries are all from the real-world scenarios. We have 4 queries. Each query is sent to 2 databases. One is TiDB, this one is TiDB, and orange one is Aurora. So I'm now going to refresh this page and try to show you the performance comparison. Okay, as you can see, all the results for TiDB comes up very, very quickly, less than 10 seconds. But for Aurora, we'll have to wait for a while. Yeah, okay, so already 15 seconds passed. We are still waiting. You can see this timing here. Okay, one finally comes out, and we are still waiting for the other 3. So as you can see, with such a small dataset with only 2.8 gigabytes dataset, we already see a huge difference. Yeah, we're still waiting for the last one. That's only 2.8 gigabytes data set. Okay, so on this dashboard, we send the one query to two database, exactly the same query, exactly the same data set. But as you can see on the left-hand side, TiDB responds very, very quickly. But on the right-hand side, Aurora, we have to wait for quite a long time. Okay, getting back. Okay, so we are now jumping to those queries. Those queries are from real-world scenario. Okay, so the first question was how many trades are there every day? I'll kind of give you 5 seconds to actually think about how to write this SQL query. Okay, recall we have a ER diagram. So so to calculate how many trades are there every day, what we need to do is maybe only query the events table, right? So here's the SQL query. So we first count how many events are there, and then we group by dates, and then order by dates, so that after we do the order by dates, we can see we can plot all these results on Retool. So for the first query, the TiDB used 1.7 seconds, while Aurora used more than 10 seconds. And here's the result. Okay, moving on to the second query. How much ETH currency is traded per day? Again, 5 seconds. Okay, 5, 4, 3, 2, 1. Okay, so for the second query, we might also only need to query the event table. So here's the query. This time, the only difference is previously we just count how many records are there, but this time we do sum. We sum order price. Again, we group by date and then order by date. That's how we get the results. So this time TiDB took less than 1 second, but Aurora used more than 32 seconds. This is for query number 2. And for the query number 3, it's a bit more complicated. So what are the most expensive assets in Q1? You can also think about it, how to write this query. In this question, I asked about Q1, but the time range can be quite flexible. You can change to any time range. Okay, so for this query is a bit more complicated. So we are going to find out the most expensive assets and what the collections it belongs to. So that's why we'll have to join event tables, collections tables, and asset table. So we have a two-way join here, and then we set out the payment symbol to ETH and time range, and then order by event total price. So for this query, TiDB used less than 10 seconds, but Aurora used more than 42 seconds is the result. Now moving on to the last one, what are the top 50 popular collections? You can think about it for a few seconds. Top 50 most popular collections. So we have event tables. We also have collection tables. Maybe these two tables, we can join them together. Yep, that's how we solve this problem. We first join these two tables together, and then we do the sum, event total price, and then group by and order by, and finally put it into a descending order. So for this query, TiDB used 1.4 seconds, while Aurora used much longer time. Okay, here's a summary of the TiDB and Aurora performance comparison. All these queries are from real-world scenario, real-world data. In overall, TiDB is around 4 to 10 times more faster than Aurora. But does that mean TiDB is 4 to 10 times more expensive than Aurora? And the answer is no. As you can see here, TiDB is a bit more expensive than Aurora, but the costs are comparable. One is a bit more than $7 per hour, while Aurora is a bit less than $7 per hour. Okay, cool. Now I will hand over to Kolbe, who will be tell us why TiDB is so efficient. Cool. I will stop sharing.
Yeah, thank you. Let me put my headphones on real quick so that the audio is a bit better for everybody. Okay, hopefully you have the audio from my headphones now. So what I'm going to do is basically just share my screen, and I'm going to show you a lot of really text-based stuff about what's happening in TiDB when these queries are executed. So let me share the right window. Hopefully what you see here are these queries that we just talked about. So these are just in an editor on my Mac, and I'm connected both to the Aurora instance. This is the live Aurora instance that we were just using, and this is the live TiDB cluster that we were just using for that demo that Chenhao did. So I can take these queries and we can actually look at the explain output for them. So if I paste this here, execute that. Whoops, I did that wrong. Let me try to redo that. No, this is the problem. It takes a while when we do it on Aurora. So now I'm going to redo the explain here. So here we can see the query execution plan for this query on Aurora. And what we notice is kind of this is the dreaded execution plan for a MySQL database. We have null possible keys. It can't use an index. It's just going to have to scan the table. It's also going to use a temporary table, and it has to do a file sort. So we're kind of hitting all the marks here for why this query doesn't perform well, when we saw that it takes about 10 seconds in Aurora. So let's try the same query now in TiDB, and we'll see the explain plan here looks a lot different than it does for MySQL. So if folks in the call are not familiar with TiDB and what TiDB explain plans look like, I'll just take a moment to provide a little bit of detail about that. So instead of the normal explain plan that we see here, where it's kind of all just what's happening on a table by table basis, we actually split out all of the information that's happening in the explain plan into a step-by-step query execution diagram, basically. So you see that this is indented. It's showing us down here that there's a table scan actually happening, but we can see based on this part that the table scan is happening in TiFlash. So what is TiFlash? Well, TiFlash is the column store component of the TiDB cluster. So we're not actually getting the data from the row store. While Aurora has to scan through basically what is a glorified InnoDB table space to get the data, we're able to use a column store. Well, why is that better? Column stores are really useful for analytics. So in this case, this is kind of an analytical query because we're doing a group by and we're doing an aggregate. In this case, the aggregate's a very simple count star. But when we execute this, we can see that it executes in TiDB, as we saw earlier, in like a fraction of a second. Whereas in Aurora, when I accidentally executed this query, it took about 10 seconds. The reason is that in the execution plan, we can see that we're pushing down all of the work for this query into TiFlash. TiFlash is actually able to collect together all of the details about this almost instantaneously and return them back to TiDB. Some people might ask, well, hey, if you know you're going to do this kind of query on Aurora, you can add an index. Well, it's not that easy to add an index. If we look at the table, we'll see that we have this event time column, and that's what we're actually using for our grouping and our ordering. And if you know you want to group by date, then you have to add a new column that has the date, or you have to add an expression index on just the date. And then you might be able to use that secondary key to provide an efficient execution plan. But the cool thing about TiDB is it's not just the date. We can do by week. And it's going to be just as fast. We can do by year or by hour, and it's going to be just as fast as it was when we grouped by date. So if you wanted to get that flexibility in a system like Aurora, you would have to add secondary keys for every one of these different dimensions over the event time column. So that's one thing we bring to the table with TiFlash, is that you have this really flexible way to execute these analytics queries. And this data, even though it's coming from TiFlash, is completely in sync with the data that's in the row store. So in TiDB, the row store is the authoritative data store, and TiFlash, the column store, is always in sync when you execute a query. So we're getting analytical query performance from a column store that's synchronized with the operational transactional row store. Let's take a look at the next query and see how that one compares. It's really going to be a similar story. So again, same thing. We got no keys. We can't do anything. It's like, again, this like classically ugly query execution plan for a MySQL compatible database. Then on TiDB, once again, we're pushing all this work down into TiFlash. TiFlash is scanning the table, but using the column store and returning results in a super efficient way. Things get a little bit more complicated, of course, here when we start doing a join. So the previous two queries were only using a single table. They were only using the events table. Now we're joining the events table with the collections table and the assets table. So how does that affect the execution plan? Well, let's take a look at what we get in Aurora for this one. Now, Aurora has a couple possible keys here, but it's choosing no key. And part of the reason for that is that it decides that it's going to have to scan that table anyway when it joins it against the other tables. So when we do this query in Aurora, I forget how long this one took. It took, I think, quite a long time. I guess we can start that up while I show you the behavior of the same explain in TiDB. So we'll just execute that and come back to that later. Meanwhile, over here, we see this execution plan where, again, it's not only pushing down the computation to TiFlash, but it's actually pushing down the entire join to TiFlash. So we can see here, when we see stuff like exchange sender, hash join, all of these things, all these senders and receivers are actually part of the MPP framework inside of TiFlash. MPP is massively parallel processing. So you can basically continue to add TiFlash nodes to your cluster. Data will automatically be spread across those TiFlash nodes. And then anytime you execute one of these analytical queries, all of the TiFlash nodes that have relevant data will talk to one another to resolve the query, and then they will collectively return the results of the query to the TiDB server. So that's how you gain this scalable analytical performance in a system like TiDB, where again, we have the authoritative row store, and then we have the scalable push down column store where we can use MPP to execute queries on the storage nodes themselves and return the results to TiDB. So if we execute this query in TiDB, I forget, this one's like 1 second maybe or something like that. Okay, about 3 seconds. And over here it was 23 seconds in Aurora. So that's a pretty big difference, right? And again, in a lot of these cases, it might be possible to make these queries in Aurora a little bit more efficient by adding some indexes, by changing the structure, by either denormalizing tables or restructuring things so that you don't have to do joins. But that kind of goes against the idea of making a relational database work well and having a data model that makes sense and making transactions usable. So being able to leverage something like TiFlash allows you to execute these analytical queries while maintaining a reasonably normalized database, using RDBMS concepts that you're familiar with, and not having to get a bunch of hacks in place to kind of force RDBMS to use analytics by doing a ton of denormalization or something like that, or having to maintain 1 million secondary keys. Finally, this last query, again, this is probably going to be a really similar story. I'm saying probably because I'm doing this live. We're watching what's happening. This is the live system. This is live data. This is, kind of a classic explain plan. So I don't know that there's a whole lot we could do to improve that. But if we execute this select here, we'll go over and see how this one looks in TiDB. And, again, that's a very similar story where all the work for this analytical query is being pushed down into TiFlash. You're seeing here that the actual summation operations are being pushed down as well. Let's see if I can figure out where that's actually happening here. Yeah, so we're seeing that the sum function is actually pushed down into TiFlash. So again, in a scenario where you had multiple TiFlash nodes, each one of them will be doing its own work to sum up the data that it had, coordinate that with the other TiFlash nodes, and then they would all be able to send that back up to the TiDB server where the query is being executed. So this one's going to take us 0.7 seconds, and over here took us 44 seconds. So a difference of like 50 times faster. That sort of speaks for itself. And I believe that this cluster, Chenhao, correct me if I'm wrong, but I believe this cluster only has a single TiFlash node. Is that right?
Single type. Yes, that's right.
Yeah. So MPP in this case, there's nothing really parallel that's happening, but you're pushing down the functionality, the execution, the computation into the storage node. And you would expect as you grew to have more storage, it would make sense to have more TiFlash nodes. And then again, the data would be spread across those, and those nodes would be working together to resolve the query. So we not only have the scalable key value store in TiKV, but we also have this scalable column store with scalable cross-storage, multi-parallel processing that can happen. So one other thing I want to point out while we have a moment, if we go back and look at some of the earlier queries, well, scrolling back in my CLI is a little bit painful, so I'll just copy this one again. But one thing that's pretty cool, so I showed you how we can see that this is using TiFlash. In TiDB, we can tell it that we actually want to use TiKV for this and see what that looks like. So we can read from storage TiKV, and we'll give it the events table. So that shows us, and now instead of using TiFlash, we're actually going to be able to push this down to TiKV. I think for this query, it's not going to make a huge difference in performance because, again, we have a single TiFlash node. It's a relatively straightforward table. But let's just try to compare and see what happens, just for fun, what happens in terms of performance here. So this query takes 1 second in TiKV. So this is not using TiFlash even in this case. And I don't remember how long that one took here, but let's see what that one took in Aurora. I think this took like 10 seconds in Aurora. I was going to have a drink of water, but my water is empty, so I'll take the time to pour myself more water. So again, the first query, we showed over here that even using TiKV, not even using TiFlash, we still have a 1 second query execution time. The same exact table structure over in Aurora, same query, took 10 times as long. And that, this is not really necessarily an analytical query. This is just a query doing a simple count star. And that was still way faster in TiKV than it was in Aurora. And for the more intense analytical queries, we can see that the payoff of TiFlash in the TiDB cluster is that much more. So that's basically what I wanted to demonstrate. I wanted to show you guys how to use Explain to compare the execution plans between Aurora and a TiDB cluster. I wanted to talk about how TiFlash works, how TiFlash is part of the TiDB cluster. It's in sync with the TiKV row store. And you can see the comparison in performance between these two solutions. So that's what I wanted to share. I'm happy to answer questions. Okay, great.
Cool.
Thank you.
Yeah, I'll take it over here. Okay, let me share the screen. Okay, so Kolbe just now showed you that HTAP solution does have some advantage. So just repeating his words, so for TiDB, we both have a raw store and column store. So when these two stores are put together, that's going to serve OLTP queries and OLAP queries at the same time. And we also have a smart selection algorithm, which can automatically send your queries to either TiKV or TiFlash. So the advantage of the HTAP solution, that's going to make your architecture much more simpler. And also, it will shorten your time to the market, and it also will lower your hardware and operation costs. You don't have to, unlike traditional solutions, you will have to an OLTP database, and you will also have to have a data warehouse, and you have to do complicated ETL between. That's going to make your architecture super complex. Okay, cool.